Hello, welcome to Modern Application Development. In the previous sessions, we have discussed CLI and GUI apps, and we have seen how to evolve those apps into a web app by using a GUI program. To begin with, we will look at how we have done the evolution and get a clear idea of the changes in the control flow and the internal architecture of the applications. After that, we will move on to start thinking of URLs as programmers rather than as users. Although all of us are familiar with URLs as objects that we use daily for various web applications, we have usually thought of it as users rather than as programmers. And as you will see, quite a few technical details come up when you think of them as objects relevant for programming. Our next step will be to look at the HTTP protocol and study the tools that allow us to inspect what is going on when HTTP is used. Lastly, we will study web browser dev tools, which are fundamental tools for any web programmer. During this session, we will be doing several demos, and you should have the following programs ready. You can use a distribution like XAMPP, which has things like Apache and MySQL and so forth, which you may have already installed for the previous session. If not, you can try doing that now. The other programs we need will be those like SOCAT or SOCAT, NSLOOKUP, and curl. These are available on most Linuxes or on Windows, certainly via Cygwin, and in some cases, native versions might be available. In this session, we are going to go over fundamental ideas that underlie web programming. These ideas constitute of a mass of details, and it will take some time for you to get these ideas organized together, but stick with it because these ideas underlie much of what is to come. As we develop our app, you will start to see how these ideas play their part in different pieces of the application. To help you organize this, I want to emphasize the big picture view, which you should keep in mind, and then slot these ideas in different parts of the big picture as we go ahead. The main theme is that there are three key components whose interactions define web infrastructure and as a result define application behavior as well. These three components are the browser, the HTTP protocol, and the server. Let's see how these three work with each other. Okay, so on the right are all the elements and the interactions that we are going to study in this session. We all know what the overall idea is. We have a URL such as NPTEL-NOC, and the browser, when it is given this URL, it somehow figures out where the server is located. This happens in step 1 and step 2, where the browser interacts with the domain name system, which converts the host name into an IP address. Once it has the IP address, it establishes a TCP connection and then runs a HTTP request on it. So something unusual is happening here. The connection is in one protocol and a different protocol runs on top. Exactly what happens here is precisely what we are going to figure out in this session, so that by the end of this session, this diagram will be meaningful to you. In steps 4 and 5, we have HTTP request and response. And there are quite a few intricate details that you have to get right in order for these request and response behaviors to help put together the web in a scalable way. And as with all programming, although the big picture is reasonably clear-cut, it is in the details that things get interesting. Okay, now let's go ahead. In the first part of this session, we will review how we changed the CLI app to the GUI app to the CGI web app, looking at the details of what changes we made to the internal architecture as well as the control flow between different parts of the system. So let's begin with the standard CLI app. Here we have three parts of the CLI: the user, the program, and the database store. And as we all know, it's a pretty straightforward thing. The user puts in command arguments or standard input. The program does whatever computation. It comes back with the response and prints it out. It feels to us exactly like a function call, and indeed the internal architecture of the code is also very similar. It's simply a series of function calls that runs computations and saves data. At most, if there are multiple commands, then we will loop over them. Also, we notice that as far as the shell language is concerned, the CLI appears exactly like a function call. We programmers can think of it as a function call, but normal users will think of it as a command. The next step in our discussion is the GUI program. In the GUI program, we made quite a few changes. In particular, the program had to be split into a view part, which shows you what the part that the user sees, and then there is the model where computation is happening. The two parts are linked by handlers, which in most cases, as we have seen, are simple references that tell parts of the view which parts of the model to change. And the control flow here, as we have seen, should now be familiar to us. When you run the app shows the view. There is an event loop which looks at button presses. Then you collect the field data and run whatever command the button has asked you to. Then you update the model and then finally update the view and show whatever the results might be. Internally, the architecture changes as we discuss below. What happens is that the program gets split into quite distinct parts. One part is responsible entirely for the looks, the other for the computation, and the two parts are linked using handlers, plus the event loop, which takes the job of keeping the program going, listening to users' requests and responding until the user decides to terminate the program. From these two programs, we constructed the web program. So let's compare what it looks like relative to a GUI program. Just as there is a view and a model in a web program, there is the two components, the browser and the server, for a web program. This time, instead of handlers linking the view and the model, the HTTP protocol connects the browser and the server. The analogy between view and model in a single application versus the browser-server distinction is reasonably accurate for simple applications, but as we have discussed earlier in the GUI session, the analogy can get quite complicated as the complexity of the browser and server programs increases. But that's for a later time. To begin with, the analogy is very useful in understanding what is happening here. The next step that we go to is to look at the internal architecture of how it is that we build the server program. And in our case, we achieved what is essentially a hybrid. We took the command line program, repurposed it, and let the server execute it. So let's go through the sequence of what happens here. The browser presents the initial UI, which is written in HTML, and listens to user actions and records user data. The browser then converts user data in a way that fits the requirements of the HTTP protocol. The server then converts protocol data into environment information for CGI bin program. If you compare the CGI bin versus the command line program, what we notice is that they are by and large the same, except that the way in which they connect to the environment in which they execute differs. So instead of getting input from just the command line, the CGI program gets its input from the environment variables as well as standard in. And after it is done, it prints its result to the standard output, which is in turn read by the server. The server then formats it in a form that works for the HTTP protocol and sends it to the browser. In turn, the content must be such that the browser can interpret it and display the response, getting ready for the next cycle. What is novel, besides the split into the model and view part, is that the browser and the server and the database program can exist on separate machines. So it's as if there is a kind of a fission going on from the architecture of the GUI to the architecture of the web program, and some aspects of the command line program can be preserved in this view. Okay, so what we have achieved is a program that is basically a kind of a hybrid. Like CLI, as far as the computation part is concerned, it is essentially the same cycle: give input, produce output. Like the GUI, the user experiences a continuously available service. But because we have introduced a model and a view, you get some aspects of a continuous user experience, even though the underlying program is much like a command line program. Our next program, however, will be much more GUI-like. Our initial CLI packaging gave us only the model view separation, but unlike a GUI program, there are no button-based interactions. But before we go on to that program, first we will study the HTTP protocol that connects the browser and the server, and we will see what it does for the programs that we have written so far. Let us summarize what we have seen of the interaction flow so far. CLIs have a function like flow with no memory access across invocations except as stored in the database. In a GUI, you do retain some history in memory, and we get the important new ability for the user interaction to depend on how the user has interacted so far. Our hybrid program provides continuous interaction without any in-memory retention, because all the retention happens or should happen on the server side. But the way the CGI program is written, it is essentially just a repackaging of the command line program. On the other hand, something important has already been achieved. Because we have moved our program to the web infrastructure, we will find it very easy later, even if we were to keep the program just as CGI bin, to add more facilities like multiple users and the ability for distributed users to share this program, as we all know from web apps. So besides the GUI-like behavior, this is the other important thing that the web infrastructure gives us. And in later programs, we will see that you can recover the ability of the GUI to retain history by using cookies and other session indicators with ways to remember session data on server side, which is distinct from the computational data, but those are things that we will come to later. For now on, we will head on to study URLs and the HTTP protocol. So that's the next part of our session. In this part, we will take a look at the components of the URL, especially query strings, and other aspects like ports and localhost. These are details that will start mattering when we start thinking of URLs as a kind of an interface to a web application. So, although we are familiar with them from daily use, we need to understand them together as componentized interfaces plus participants in the HTTP protocol. A protocol is a set of rules that is implicit in any two entities that communicate, whether it is people or whether it is computers. And the details of how that communication happens matters in all web programming. A URL is the acronym for Universal Resource Locator. It is, as it says, a locator, that is to say an address for a resource. The structure of a URL is of the form protocol : / hostname : port / path. This structure has two important parts. One is the hostname and port, which identifies the server, the path, which identifies the resource inside the server, and the protocol, which for most common uses just turns out to be either HTTP or HTTPS. For example, in http nptel.ac.in/noc, the protocol is HTTP, the hostname is nptel.ac.in, and the path is NOC. We can think of this as a resource locator, but to the browser, it functions like a set of instructions. When the browser is asked to fetch a URL, it takes the following steps. It first looks up the server at the name nptel.ac.in, which is then located in the form of what is called a IP address. Some of this you may already be familiar with, but I'm going to repeat these things in detail for those who aren't. The mapping from this name to the IP address is done by something called a DNS, which we will briefly take a look at later. Then the next part of the instruction to the browser is that having located the server, the browser should use the protocol HTTP to talk to it. As part of talking to the server, it sends the path NOC to the server, and then the server takes over. The browser now just waits for the server to return the contents of the URL, and here is what the server does next. It receives the URL and interprets it as the following sequence of instructions. First, verify that the server is supposed to act as the server called nptel.ac.in. This is done by means of configuration that is known to the server. The next step is to take the resource at the path NOC, which it knows how to locate, again by means of various configurations, then read the contents and send it back to the browser. The resource here is just what we can think of as a bag of bytes. Usually it's an HTML document, but also, as we know, PDF and video and various other data formats are also available as resources. The path component of the URL is also called the request URI. We will summarize these technical terminology such as resource locator and hostname and protocol, etc. later, but those are more familiar to us. As programmers, it is the new unusual terminology like request URI that becomes important in discussing just exactly how we program the web. URLs like nptel.ac.in/noc are the simplest kind of URL. There are many more complicated URLs that we will have to take a look at in a minute. So let's begin. The next kind of most common URL is what is called a URL with a query string. Try the following. Go to any page on Wikipedia, say enwikipedia.org Madhav of Sangamagram, and then at the top right you will see a search box. Now type URL in the search box and hit enter, and then look at the URL in the browser. You will see a complicated URL of the form shown below. And now let's try to identify the parts of the URL. In this case, we will see that the path, or what is called the request URI, is this part that I'm going to highlight. It is /w/index.php. The part after the question mark is called the query string, and in the current example it has things like search and title and so on, and we go on until the end of these special characters. So this part after the question mark is called the query string. You can think of this as a different syntax for function calls. The parameter names of the function are things like search, title, and the part after every equal is the parameter value. You can directly type URLs like enwikipedia.org, etc. and put a search term directly in the browser, and it will have the same effect as doing the search from the box, even without some of the extraneous parameters that come from the box. So let's try this out. Okay, let's try out the case that we have just seen. Here we are at the Wikipedia page for Madhav of Sangamagram, and here we have the search box with URL written in it. If we hit enter here, now we can see the URL with a query string which contains things like search and title and full text search, which tells us that we have asked Wikipedia to basically look at everything with the word URL in it, especially the ones with title containing URL. And like I said, we can now go to the query string and remove the URL part and put HTTP, and now you will see that here we are getting everything about HTTP. For example, Hypertext Transfer Protocol, HTTPS, etc., etc. A somewhat different behavior happens if you remove the extraneous parameters and try just HTTP. Now, because there is a unique page desired, we go straight to the HTTP page, and notice something. The URL, although we typed it as in the query string form, has changed into a normal looking URL. We see further interesting behaviors once you start becoming aware of how the URLs are changing. For instance, if you search for the phrase query space string in the search box, you will see that the browser URL turns into query plus string. For example, in the Wikipedia case, we have search equals query plus string followed by the other search parameters. For various reasons, characters like blank spaces are turned into special encoded sequences. One reason for this is that sequences of non-space characters are often easier to work with in programs, but there are other historical reasons why certain encodings exist. There are many unusual details like this that matter in web programming, and as a web programmer, you often learn these as you go on, but you have to be aware that they exist. One reason why there are such strange rules is that the web grew somewhat like a biological organism over 25 years or so, and as a result, it has an agglomeration of all sorts of peculiar rules that were created when different people made changes to the web for different reasons, and the web we see today is actually a result of all those changes at the end of so many years. So, how do we deal with these peculiar rules? Most of such rules were created, like I said, for reasons that were good when they were invented, but now they have simply been absorbed into the ecosystem. From time to time, I'll point out these kinds of things to you, and you should also keep your own list of things that you will notice. For me, after so many years, many of these things have become second nature, but for you who are encountering them for the first time, making a list is perhaps the best thing you can do. In the end, they will become familiar to you, and you will be able to look up sites like Stack Overflow and Wikipedia as needed for idiosyncrasies which people used to know at one point in time, talked about it, and luckily for us, they are available for us to learn from. In all this, experimentation is essential. You should build small trial websites on your own machine where you try out the rules and understand them in detail. Luckily, unlike scientists or other people who need to work with physical things, our experiments don't need very many resources. They just need time and patience. The next component to think about is a URL port. In addition to the server name, a URL can have an explicit port in the form, say, 8080. This URL doesn't actually exist, but the site example.org exists. Example.org was a site created in the early days of the web for the sole purpose of being, like it says, an example. And in a short name like example.org, the port 80 is actually assumed. You can pause this video now and go visit example.org to see what it says. The port number, because it is common for most URLs, when it is 80, it is not mentioned by the browser. You may have noticed that browsers nowadays even hide protocols like HTTP, although at one time they never used to do things like this. So what is a port number? A port number for a server is associated with a particular service. For example, the HTTP protocol uses port 80, HTTPS uses 443, FTP uses 20 and 21, and so on. If a server's IP address is like an institution's phone number, a port number is like the extension number for someone's office in that institution, and the complete address for a person in the case of the office is both parts. Similarly, the complete address for a service is the name of the server followed by the name of the port. When you run your own web server for practice examples, it is often useful to have more than one web server running on different ports such as 8080, 8000, 8001, etc. Port numbers below 1024 are reserved for many purposes. So practice site ports are often 8 related. For historical reasons, you can use any name you want, any number you want, and it makes no difference. So let's see how it looks like to run multiple local host services on your machine. As we have seen from the previous session, web servers on development machines can be addressed using the special host name localhost. For the local web server, we can use http://localhost or https localhost. Typically nowadays, web servers like Apache will be configured to present both HTTP and HTTPS endpoints. An IP address will also work instead of the host name. For example, for the local host, you can use 127.0.0.1. And on the web server on your machine, you can try starting Apache at different ports. To do this, you have to be able to change the configuration for Apache or any other web server that you use. For whatever web server you use, search on the web with a query like how to run Apache on port 8080, and usually the first answer will tell you exactly what to change in the configuration. Alright, now that we have seen quite a few details about URLs, let us summarize them. URLs are addresses of resources, where a resource is a data set of some kind. Usually the data in a resource is in HTML format, but others like PDF, JavaScript, JPG, etc. are all common. A URL consists of a protocol, a host name, a port number, a path, which is also called a request URI, and possibly a query string. A URL can encode special characters like space, tab, /, question mark, etc. in different ways. A query string is like a function call. It has parameter names and values that are separated by equal characters. A port helps a single machine offer multiple services. This terminology is so common that we will be having exams and assignments that ensure that you learn this terminology well. Alright, so now we are done with URLs, and our next step will be to look at details of the protocols. So let's pause here for a minute, and we will then go on to the next part of this session.